from Inspiration Metalworks, and welcome to another shop update. We are on episode 22. Wow, 22. And this one will wrap up our project that we're doing with Gary Ramsey of Ramsey Customs. So in our first video, we looked at the graphics and the differences between raster versus vector images and how we get graphics into CNC systems. The second video, so last week's video, dealt with the interactions that we have in nailing down the actual design of the part. What is it that we're going to make? What are the critical dimensions? What do we find out from the customer about what they're trying to do with it, right? So all of that information that we need to know to get us to this next step, which is actually producing the part. So in today's video, what we're going to look at are some ways to optimize the cut paths that you use to make sure that you're getting the best parts available, and the way that we optimize the speed and amperage of the plasma cutting system to make sure that we're, again, getting that best balance between good quality parts and not taking days and days to make it, right? So let's sit back, and I've got a couple of videos here. We actually recorded the cutting stuff first the other day. I had some friends over that were able to help me move the metal around. We cut these out of 14 gauge and 3/8 inch steel. Mild steel, so 1018 mild steel, hot rolled steel, for those who are interested. Obviously, with my back being the way that it is, I can't lift that stuff. So did the recordings of that the other day, went back then and looked at the process that I did and made some recordings from that and editing it all together. Last thing, for those of you who are still with me on all this stuff, my back is doing a lot better. I am about 2 weeks, actually, yeah, so Wednesday made 2 weeks from when I had back surgery. I had 3 vertebrae fused and some cages put in. If you follow me on social media, you got to see some of those pictures, the x-rays and stuff like that, and we talk about it. As a machinist, I'm actually kind of grateful for the guys that do that medical grade work. So when you look at my back, it's kind of amazing. But I'm on the mend. It's still, what I'm hearing from the docs is that while I'm being a good paratrooper and you know, getting through it all, I got to be careful not to overdo it. And so I'm being very very careful with what I do, following those directions, because it would be easy to re-injure it and make it worse than what I'm at. So I'm still probably somewhere in that 4 to 6 weeks range before I'm going to be back to doing bigger projects. But I will continue this kind of work. I'll continue putting out videos as best I can. I appreciate everyone's comments that I've gotten. I've gotten some of the nicest and most helpful comments on between social media and the comments left from me directly on YouTube about this series. So I'm going to try and keep making the kind of videos you like to watch and what people are finding helpful. So with that, sit back, enjoy the ride, and let's get started. Thanks. Okay, so in the last video, we worked directly with Gary to determine what kind of cutouts he was looking for. Right? We're looking at the parts. And in this week's video, we're looking at the best practices on how we actually make the parts, speeds and feeds, the way that the CAM software portion of Design Edge works, and then optimizing all this. And you're going to do things a little differently each time. It depends on what you're making. Is it something with just a bunch of straight lines? Is it something that has lots of detail in it? How large are the parts that you're making? What's the tolerances you have in there? Does it matter how cleanly the cuts are, or is it just trying to get a bunch of parts out there and get welded over and nobody's ever going to see it in the first place? So let's focus today on some of those tips and tricks that will allow you to produce the best quality parts. And it will be up to you in your evaluation of all this on how much of this you apply for each time you make your parts. So let's focus here. I'm going to zoom you in on a couple of different things. When in Design Edge, when we ask Design Edge to create the cut paths for us, so we're not writing G code. We're letting the software do the hard work for us. Design Edge is going to basically do a couple of things, and you know what? Maybe we can let's take a look at how it does it. So let me zoom back out. This is a very, very busy sheet here, right? Because I did a bunch of stuff. So let's look at just the original. Here's our original import that we did. And remember, this is from the vector software, or I'm sorry, the vector version of the image that we created from Inkscape, right? And that we converted into DXF and then imported. This is technically like 12 feet long, right? So it's going to show up a little differently than when we look at something that's about 3 inches in height. But all we do to create these new cut paths, we can come into Machine and click Convert to Cut Path. Now I use those, Shift N. I use those shortcuts all the time because, frankly, once you learn your keystroke commands, it's a whole lot faster to do. We say Convert to Cut Path. And so you start to select what you want to convert. Are you cutting the outside or the inside? Right? This is that positive and negatives, the things that we talked about in the last video. So let's assume that we're creating a positive on this one. And I select an area where I want the cut path to start. And yeah, we're not on the table. It's prompting me. Do we want to do this? And it also detects that there's going to be a hole automatically created. So do I want to do that? And I can say yes or no. Most times I just say yes. So there it is. You create some things. I repeat the process here. Yes. Here's one that's got a few more things. Yes, we want to do it. And yes, we want to create the holes. Right? Yes, we want to do that here. And so I would repeat this process for each of these different parts that I want to cut. Right? Now we're keeping in mind here that this is a 12-foot size rendering of it, right? So I'm going to press Escape, I'm done, and let's look just at what maybe the R is going to look at. So let's zoom in on just the R. And so if we zoom way in, you can see I've got some lead-in, right? And you can adjust your lead-in settings because it's got a lead-in, and then it goes around and it cuts everything. And on something really large, right, I come through, even here, you notice as we zoom in, that cut path's going to come in, it's going to cross over itself actually, come back, down, and around. You're not going to get a sharp point, you're going to get a rounded over edge. Alright, so let's go back to our table, and actually before we do that, I'm going to go back and I'm going to do actually, I'll revert. I want to get rid of all these cut paths that I just put in here, so I don't actually do that. But let's go back to our table, and let's look at. Now, this is the size that that Randy wanted done. Randy, I keep saying Randy because I see the Ramsey. Gary wanted done for his positives. These are 3.5-inch tall letters, right? And so as we start to look at what the automatic cut paths did for us, and this is the ones where we joined some pieces together. As you recall, we started cutting a few pieces away, but as you start to look at this, you'll see there's an awful lot of this crossover all over the place. In fact, any place that there's a sharp turn, we're getting this crossover. Here, let's look at the part in the Ramsey, the AMS part of Ramsey. At every little turn here, it's automatic, like even for the M, it comes down, it crosses over, comes here, then crosses back again, right? So what you're going to get here, if you get anything at all, is you're going to get very sloppy looking lettering, right? So what I do to prevent that is I actually go in and we'll zoom out, and this one's already done, and then I'll show you how we get to that, right? What I do is I go in and I clean up these cut paths. In this case, I knew that I wanted it to be very, very crisp and clean. For instance, I'll zoom in. So down here at the bottom where that R crosses, let's look at what it looks like after I've cleaned it up. And you can see that cut path comes in and stays nice and sharp. Now remember, plasma is a spherical, a plasma cutter, it's basically shooting a sphere. It's kind of like water coming out of your tap, right? Or anything else. It's round. So I'm not going to get a perfectly sharp point on an inside cut here. But I can do my best to clean these things up and make them work better. So let's cut away. I've actually already done the cutting on all this. I wanted to show how this optimizes. So we'll cut away to what the cutting quality looks like when we do the unoptimized versus the optimized. And then we'll talk a little bit about optimizing the settings of your cuts themselves. So first, we're just looking at the path that the cut's going to take. The next part of this is we'll look at how we optimize the cutter and the way that the machine is going to work for you when you make these cuts. Alright, in this short clip you can compare the optimized cut paths versus the unoptimized. If you look at the C, it's very obvious. The top of the C, in the bottom version, you can see where the overlaps happened, whereas in the top C you can tell where I had cleaned those cut paths up so that you didn't end up with this extra holes where there's supposed to be metal. Okay, so let's take a look at how we made the optimizations here for the cut paths. Let's make sure I'm in the right spots. Let's look at this one here. So this is the automatic cut paths, and let's look at what I did to get from this version to the version I ultimately used. And I'm not going to go through and do the whole thing, but I just want to show you how simple it is to make these adjustments in Design Edge so that you can clean things up. We were looking specifically at this part of the R, so let's zoom in. I'm using the F1 key to zoom in to where the mouse is. And let's look at that crossover. Right? Here's my drawing lines, here's the automatic cut paths. What I do is I use the trim command, the trim extend, right? I basically say, hey, get rid of those. Notice, though, there's a leftover part. So press the escape key to end it. Select your leftover piece so you don't end up accidentally still cutting it. But now we're here with a broken path, right? Well, all you have to do, just like with a broken line in the drawing, is you can press the link button or the J key, and it makes your cut path, solid again. So I go through, I basically start at my lead-in point, and I just start working my way around. Sometimes they're hard to see. If you look really closely, we'll start zooming in here. We'll see that, hey, there's something here. And we're going to zoom way, way, way in and confirm, okay, this crosses over, right? This is a good example. Crosses over. Press the X button, that, trim, and we can just get rid of that piece. And clean it up here. And then we join it and it fixes everything back, right? There are times where it looks like that, and maybe I think it was this one. Let's look again. Let's zoom in on this one. It looks like it's crossed over, but look, it's not. It doesn't cross over. So if I try to just trim this, it doesn't know what to trim because there's no crossover path here. These are the ones that are going to catch you. This is your gotcha moments, right? If I go back, we zoom out, and I assume, if I make the assumption that this is the same, oops, and there was some left over here, so let's get rid of that. If I make the assumption that this crosses over, and I go to trim that, watch what happens. Oh, I lost that whole line over here, right? So let's go back. I use the page up button to undo, and we'll zoom back in far so we can see. And let me show you a variation on this and how I do it. Trim can also be used to extend things, and we're also we have another piece in there called the break command. And break, which is where here. Okay, use the break command. It's K, by the way, the letter K. The break command lets you split things apart where you want to. Now you have to watch about your snaps. If you have node point snaps turned on, it's going to want to do it at these node end points, right? So make sure they're off. But basically, what I do in this situation is I press the K key, or I'll say we're going to do a break. I break it someplace here. I break it someplace up here. And now I've isolated this section, right? So that I can just delete it. I press the delete key. And now the trim becomes extend. Remember, because this is trim/extend. It is context aware. It knows what you're doing. And so in this case, we're going to extend it so that it reaches out to it. And now we'll trim it. And I didn't have to make any changes. It's context aware. I'll press escape. We'll join that path together using the J join. I don't know why they call it link here and not join. It seems like it would be better to do, keep in line with the shortcut key. But hey, that's that's not something I control. We'll use F6, or maybe we'll go back to. Oops, here we go. And you can see. So now I started working my way around. I cleaned this one up. I cleaned this one up. And I'm going to work my way around every single letter and clean it up. It takes some time. And this is what I was talking about on whether or not you want to balance, or you have to balance the quality versus the, what's good enough for this one versus the time and the cost, right? So this is how we do it. This is how I go through and clean up my cut paths. And with that, let's go back now. Let's do a little more review, and then we'll talk about optimizing the speeds and amperage. I always want to say speeds and feeds for my mill and lathe stuff, but speeds and amperage, and we'll look at that. All right, we're back to Shaky Cam 3000, but I want to point out a couple of things here. 3 cuts, 3 sections here. None of them are absolutely great, but let's point out the biggest differences here. So the left one here, this one. This is default cut paths and the recommended cut speed. So we're at 260 inches a minute. And look at all this. I mean, it about melted away here. It about fell apart, right? Here, in this middle one, we optimized the cut paths, but we didn't do anything with the speeds and amperage at that point. So we still start to get some extras or some bleed through, but you notice we're not coming down quite so much in here. The lines are getting better, but they're still, wherever there's transition, there's still shakiness, right? I don't know how you can see that. Maybe if we turn it, you can start to see how wavy that is, right? And then the last one is when we use our optimized speed and feed. Our optimized cut paths and speeds and heat. And so you start to see, I have a little bit in here I'm not real happy with, but our lines are much smoother, they're much more defined, and as we get the dross off of the back of this will actually clean up and look a whole lot nicer. So that's why it's so important. Remember, when you look at what you're doing, being able to balance it, defaults, improve your cut, just your cut paths, improve cut paths, and optimize your machine settings at the same time. Okay, so obviously optimizing your cut paths makes a big difference in the quality of what you receive. And again, some of that doesn't matter based on your size of the cut, the parts, the what it is that you're making. Sometimes, frankly, there are times where I just click the button one time, I let it do its cut paths, and I don't touch it because it's good enough. And you have to make that decision. Sometimes you're making it for yourself. Sometimes you're making that decision with the customer on what's good enough, because you've got to have a balance between the amount of time you put in to clean this up, and you clean the drawings up and the cut paths up, and the improvement in quality that you're going to get. The other thing that you'll note that makes a huge difference here is optimizing your machine for the types of cutting that you're doing. Not just the material, but what I'm really referring to here is speeds, feeds, your amperage, things like that. In the very first one that we did, where we didn't do any optimization on this one down here, we also went with the default book values that Hypertherm provides for machine cutting. With its, in my case, it was for, I've got a Hypertherm PowerMax 45. So at 45 amps for 14 gauge steel, which is what this is, it wanted us to actually cut at 280 inches in the
So obviously you can see we had a lot of problems on this. It was blowing out the material, it wasn't cutting properly. In this case we even had an arc strike where we've touched off and we've blown out the material completely. So at the standard speeds and feeds with no optimization, this was so fast that basically we're left with nothing.
Remember, Hypertherm's charts are designed to give you the best cut quality. So minimal dross, good proper cut height so that the shape of the plasma flame coming out is optimized. You're getting as square cut as possible, with minimal dross and minimal cleanup required. In this case, so even with an optimized cut path, if you run at that full speed, frankly, parts of this are so small, the parts are so close together that it just melted the stuff away, right? It just wasn't the right settings for this application. So what we did in this next video, and we'll switch away to that in just a second, is I made another one. I optimized, basically I'm just copying and pasting on this stuff. But I used the optimized cut paths. I slowed the cutter down to 90 inches a minute, but I also cut back on the amperage. I went to 30 amps instead of 45. And in doing so, in that combination, what we get is a very, very clean cut with acceptable amounts of high-speed dross. There is, and you'll be able to see in the video, I'll compare the two. You'll see we get nice straight lines. The G-forces as we're coming around these turns aren't so bad that we get waviness. At 90 inches a minute, we get very nice, precise lines. But you can see the difference. You can tell at 45 amps, and I think I ran it at 260 inches a minute. There's almost no dross, almost no cleanup to do. Whereas at 90 inches a minute, 30 amps, there's a good amount of dross, high-speed dross. The nice part is that dross chips off fairly easily. So let's take a look at the differences there now in optimizing the speeds and feeds to make sure that we've got all of that as well. Or in this case, speeds and power, not necessarily speeds and feeds. So here we're cutting at 90 inches a minute. We've brought the amperage down back to 30 amps, and you'll really be able to see a big difference here in even just what you can see on screen. Okay, so let's take a look at the quality here. I'm zoomed in kind of close right now because I want to show you a couple of things. The
R on the right, that was done at full speed, full amperage, and frankly, it cuts really, really well. When you look at the cut quality on the backside, very little dross, right? However, when we look at the actual lettering, especially wherever there's movement, let me make sure you can see this. Good. Wherever there's change in motion there, right? See how bumpy that is? That actually shows up quite a bit when we're working with script. And so, if you give me just a second, we'll switch over to the 90 amp, and we'll get this. All right, so let's take a look. Let me move this out of the way. Let's look at the R that we cut at 90 inches a minute, 30 amps, right? A little bit slower, but as you can see, now here we get much better cut quality, but okay, a little bit of dross, blowback dross on the top, right? So that's normally indicating cut height, so that might have been part of it. But then on the back side, that's what we got to look at here. You see all the extra dross on the back? Now, so we have a trade-off to make here, right? I want good, clean, quality cuts. The cuts are more important. The dross on the back is high-speed dross, which means that with a chipping hammer, I typically use a wire cup on a angle grinder, clamp things down real good, and just a quick once over, and this stuff just comes right off, right? So I'd rather sacrifice a little bit of this for nice clean lettering than I would have the faster cuts, the better cut quality as far as the dross goes, but then not have the letters come out quite as cleanly. Thanks everyone for staying with me on this journey. This 3-part series. I know it actually came out to be a couple of hours worth of video, so I hope you find it helpful. If you're doing this kind of work yourself, I hope it helps you improve in your craft. It's a real pleasure working with Gary as well. He's a great guy, and I had fun with this. And I know he was a little surprised to see just how many of these parts I did as well. So those will be getting out in the mail shortly and get that out. But again, if you have questions, please let me know. I appreciate the likes, appreciate the thumbs ups, share the video, comments. I have thick skin. I can deal with it. If there's a couple areas I'll probably in editing go back and fix. I said spherical instead of cylindrical and little things like that. And I would always prefer someone make a comment and correct something that I have said wrong than spread incorrect information. So please, if I've misstated something, jump in, but try and be tactful. Anyways, thank you very much. I appreciate you joining and watching these videos, and I hope to see you again soon. Thanks again.